Hello dear students, in this lesson we are going to talk about equations. So first of all, let's try to understand what exactly is an equation. An equation is a mathematical statement which lets you know that there are two portions equal. We represent an equal sign to represent that there are two sides equal. The left side or the left portion is said to be the left hand side of the equation, and of course the right portion is said to be the right hand side of the equation. Now, both the portions may involve different components. We may have an unknown term, which is often represented using an alphabetical letter. The most popular alphabetical letter we often use as X, but we can use any alphabetical letter to represent an unknown number, and that is called the variable. We also have certain constants, operators, as well as coefficient. Coefficient, you must be knowing that it's the kind of multiple of the variable. So, how do we solve these equations? So first of all, students, we have the simplest form of equations. Those are called linear equations. We do have different types of equations, but at the beginning we're going to deal with linear equations. So how do we solve equations? To solve linear equations, we simply use the method of inverse operation. We'll be seeing them in our examples. So you can quickly notice here that inverse operations of addition is subtraction. Similarly, inverse operation of subtraction is addition. Similarly, multiplication and division are the inverse operations of one another. We'll directly jump to the questions and we'll try to understand how to implement these rules to solve the equations. Let's begin with the first equation. Question asks you to solve the equation. Students, solving equation simply means finding the value of the variable. Whatever is unknown, we try to find its value. So to get the value of our unknown, which is x for now, we have to isolate it. Means we need to make it alone. So how do we make it alone? Because 2 is together with x, but we don't want to see this 2 here. So to remove this 2, students, we have to perform the inverse operation. Just because the 2 is being added over here, what we are supposed to do, we need to perform an inverse operation. Means, as we have discussed that addition and subtraction are the inverse operations, we can subtract 2. But whatever we do at the left hand side, exactly the same process we need to do even at the right hand side. And this is how we subtracted 2 from both the sides. So on the left hand side, we are left with only x because 2 has got cancelled with this negative 2. On the other hand, we have 10 negative 2, which is going to give you 8. So x equals 8 is your answer. Let's take the next example where something is being subtracted. Again, we want to make x alone here. To do so, whatever is being subtracted, I need to remove it by performing inverse operation. So this time I'll have to add this 3 to both the sides. Whatever we do at the left hand side, the same thing we need to do even on the right hand side. And this is how we simply get x equals 15. And that's your answer. Simple. Similarly, students, if there is even no symbol between the variable and this coefficient, we imagine that to be multiplied. So we consider 3 is multiplied to x here, and as we discussed, division and multiplication are the inverse operations. So to remove this 3 from here, I'll have to perform division by 3, but the same process we need to do even on the right hand side. So this 3 got cancelled from this one, and this 3 will divide 18, and that gives you 6. So that's your answer. And finally, look at the next example. Here 7 is being considered to be divided. So in order to remove this 7 from here, students, what we have to do, we need to perform the inverse operation of multiplication. So whatever we do at the left hand side, the same thing we need to do even on the right hand side. And this is how we can simply cancel it out. 7 and 7 got cancelled here. We are only left with y, and that's equal to 21. So we can have different variables. It's just not only x. We can use any alphabetical letter in our question. Okay, So this is your answer. So these are the one-step equations, students, where we just have to perform single step and we get the answer. There may exist equations in which we need to follow a few more steps. Just like this question, students. We have to solve this equation. It still means that we have to figure out the value of the unknown or value of the variable. But to make this x alone, we need to do some extra work here. Whenever we have something multiplied to the variable, and along with that we have something added or subtracted, what we need to do, students, we don't touch our variable term at the beginning. We first of all try to remove the terms which are added or subtracted. So right now 4 is being added, right? And as we discussed, subtraction is the inverse operation of addition. So in order to remove this 4 from here, what you have to do, you need to subtract 4 from the left hand side, but whatever you do on the left hand side, similar operation you need to do even on the right hand side. So this is how my 4 and -4 got cancelled, and I'm now left with 3 times x. Basically there is no symbol between 3 and x. We imagine them to be multiplied. On the right hand side, 16 minus 4 gives you 12. And now it's simple, as you know, this is just a kind of one more step we need to follow here. We need to remove this 3 from here, and you guys know what to do. Because 3 is being multiplied, we'll have to remove it by dividing the same value. And the same thing we need to even divide on the right hand side. So this is how 3 and 3 also got cancelled. And now we are left with only x on the left hand side, and on the right hand side we are left with 4. And that's our answer. Let's take one more example. We have to solve one more equation of the same kind. This time 2 is being subtracted from the variable term. So again, we don't touch the variable term at the beginning. We first of all try to remove subtracted term by performing its inverse operation. So we have to add 2 to the left hand side. Same thing we need to even do on the right hand side, okay? And this is how my 2 and -2 get cancelled, and we are left with 4 times x on the left hand side, and right hand side gives you 16. Finally, I have to divide 4 on both the sides, so I just divide 4 here as well as here. In order to get our x, we have to divide 4, and we finally get x equals 4 divided 16 for 4 times, and finally we get our answer as 4. Simple. Okay students, so till now we have seen the equations in which variable occurred at only single place. Look at this question here. Variable occurred at more than one places. No matter variable has occurred on more than one places, but we still call this equation in one variable because kind of variable is same. Had we got y over here instead of x, we would have had a different situation that we'll learn later. But for now, just because the kind of variable is similar, so we don't have to worry about that. We can still easily solve them. So the very first thing you need to do in that type of equation, students, that you have to collect all the like terms together. Means all the variable terms you try to keep together. So right now, as you guys notice, that we have 2 like terms. We have 4x and we have 2x. And in order to get them at one side, no matter whether you try to get them on the left hand side or on the right hand side, it's still okay, there is no problem. So let us now decide to keep everything on the left hand side, means all the variable terms on the left hand side. So to do so, just because 2x is positive over here, in order to remove this 2x from here, I'll have to perform subtraction. But whatever we do here on the left hand side, on the right hand side, the same thing we'll have to do even on the left hand side. And this is how, students, 2x and -2x got cancelled from the right hand side, and on the left hand side we are left with 4 minus 2, which gives you just 2x. Also we have 7, so we keep it as it is. Now the equation simply becomes with a variable present only at a single place. Now it's just a 2-step equation after this. What you're supposed to do, as we have discussed, that we don't touch the variable term now. we try to subtract 7 from both the sides initially so that our 7 get eliminated. After that, we are left with 2 times x basically, and on the other side we have 12 minus 7, that gives you 5, and you now remove this 2 from here by dividing on both the sides. So this is how 2 also has got removed, and we just are left with x on the left hand side. 5/2, we keep it as a fraction, or we can even write it in decimal, but no problem. Fractional form is still okay. The answer is x equals 5/2. Simple. So this is how we solve equations when variable is present at more than one places. What we have to do, we need to collect all the like terms, all the variable terms on the same side, and then we try to transform term from one side to the other. Let us try one more question. Again, we have variable present at more than one places. So students, you can pause the video. You may try this question if you can. Okay, let me just try to solve it here. First of all, as we notice, we have 3x right on the left hand side, and we have just 1x basically on the right hand side. In order to get them at one side, what I try to do, I try to bring x to the left hand side. So to do so, what I do, I subtract x because it's positive over here. So same thing I need to do even on the left hand side, and this is how these two terms got cancelled. I'm left with 2 times x because 3x minus 1x kind of, right? We have then 2x, also keep -8 as it is, equals 6. Now the process is simple. You need to add 8 to both the sides and they get cancelled, and then we are left with 2x equals 8 plus 6 gives you 14. As you then divide 2 to both the sides, see 2x equals 14 we have, and we have to divide 2 both the sides, we then get x equals 7. So x equals 7 is our answer. So students, that's it in this video. In the next lesson, we'll talk more about solving equations with brackets and fractions. So see you in the next video.